Here we are for notes 3 through 5, which sounds like a lot, but it's actually all dealing with the idea of slope and linear functions in general. So the rate of change of a linear function, which is target 3, rate of change is just another word for slope. So if that confuses you to see rate of change in your brain, anywhere you see that, just think slope. So let's remember some things about slope. If we have an increasing rate of change or an increasing slope, that means the linear function is going upwards graphically. Give you a visual, going like that. Decreasing rate of change means the linear function is going downwards graphically. So from left to right, it's going downhill. The other thing we have to remember is there's a slope to help us find the rate of change. So there's a formula to help us find the rate of change or slope. So there's lots of ways to remember this. So m is actually the variable we use for slope, and the formula is y2 minus y1 over x2 minus x1. So ways I've heard this that students remember this is rise over run. So rise is goes with y and run goes with x. So rise over run would be y's over x's. I've also heard yummies on the table since y is in the numerator, that's the yummies, and then the x's with the division bar kind of make it look like a picnic table or some sort of table. I will never ask you what the formula is, so it doesn't matter how you remember it, you just need to know how to find the rate of change using that formula. So let's take a look at A. So the very first thing is finding slope or the rate of change from 2 points. Whenever you have 2 points, it doesn't matter which point you call 1 and which point you call 2. It does matter which coordinate you call x and which one you call y. So it's always x before y. I'm going to call this x1, y1 and this x2, y2, but you can have that flip-flopped. So just putting it into the formula, y2 would be 5 minus y1, which is 4, over x2, which is 10, minus x1, which is negative 3. So here in the denominator, when we have minus and negative, we change that to a plus. So 5 minus 4 is 1. 10 over 3 is 13. So this slope would be 1 over 13. This would be an uphill line since it's a positive slope. Same thing on B, just new numbers. So x1, y1, x2, y2. Filling in the formula, we start with negative 9 since that's y2, minus y1 over x2 minus x1, and then we would have negative 9 minus 8 is negative 17 over 3. And always make sure that you guys simplify your answers. So if it said 4 over 2, we would want to say that that's 2. Also, leave your answer in fractional form. Don't change it to a decimal. Sometimes we do that in other situations, but we don't want to do that with slope because we want to clearly see what's the rise and what's the run. So B would be a downhill line since it's a negative slope. Moving on to finding the slope given an equation. So given an equation, we want to put the equation in what we call slope-intercept form. Y equals mx plus b. And we know it's in slope-intercept form if the equation reads y equals, like it does on A. The reason that this is so nice is because m is just the number that sits in front of x. So on A, the number that sits in front of x is negative 1/2. So slope is negative 1/2. It makes it much easier. On B, it's not written as y equals, so what we're going to have to do is get y by itself. So we're going to use those solving skills from target 2. To get y by itself, I'm going to subtract 4x. So now I have negative 2y equals negative 4x plus 10. I can't combine those. And then to get y by itself so that it's y equals, I'm going to divide everything by -2. So we have y equals 2x minus 5. Now this is not my final answer. Remember, it's always asking us for slope on this target, the rate of change. So now that it's in slope-intercept form, we can see that the slope is 2. So an uphill line. C is not in slope-intercept form either. It's not written as y equals. And we have parentheses, which if you go back to target 1, that's a reminder that you have some distribution to do. So I'm going to distribute to start off with, since our order of operations says to do parentheses first. And then to get y by itself, I'm going to add the 4. So our final answer here, or our slope-intercept form, it's not our final answer, would be 5x plus 14. And our slope is whatever sits in front of x. So our slope is 5, again an uphill line. X equals 0. This is a little bit of an interesting case because we don't have a y, so we can't write it as y equals if we don't have a y. If you ever have x equals a number, that's actually a vertical line. And anytime you have a vertical line, your slope is undefined. Now we could also have a horizontal line, and if we had a horizontal line, our slope would be 0. So those are the two kind of tricky cases, I think. So here are 4 problems solving for slope using an equation. Next thing we're going to do is find that rate of change, find the slope given a table. So in our table, what we're going to be looking for is the rate of change, which is actually the rate of change of y. And so there's a few things that we do need to look for before we jump right into finding the rate of change. You need to pay attention to your x column. So in your x column, it should go from smallest to biggest number, and you shouldn't be skipping any numbers. So I'm going to real quick check all 3 of these tables. They all go from smallest to largest without skipping any numbers. So we're all good on there. So once you check that, look at your y values. Look at how much is added or subtracted from the first to the second. So to go from 7 to 11, we're adding 4. And that should be true all the way down because these are linear functions. They have a constant rate of change. And whatever that rate of change is your slope. So our slope on this first table is 4. Let's check the second. So to go from 1.5 to 4, and in this case it would be okay to use a decimal if you want to, we would be adding 2.5. And then just make sure that that's true for every number, every y value as you're going upwards in your table. And then again, once you see it is true, that's your slope. Let's check over here on the last one. So to go from 5 to -7, we would be subtracting 12. And we can see that that's true all the way down. So this would be a downhill line with a slope of -12. And then the last place that we would ask you to find the rate of change is given a graph. So I mentioned this first case already since this is a horizontal line. A horizontal line always has a slope of 0. So I don't really need to think about that anymore than just kind of observing that it's a horizontal line and remembering that that means there's a slope of 0. Let's take a look at B. So on B, we're going to have to find some nice points to deal with. So I'm just eyeballing this. You could pick any of these points. I think I'm off by 1 there. That looks like it's not quite a point. All right. And then let's go back to that idea we talked about at the very beginning of the notes, the rise over run. So to go from this point to the next one, I would have to go down 1 over 4. So down 1 would be -1. to the right 4 would be positive 4. And that stays true. So down 1 over 4. I feel like a really common mistake is people would just say 1/4, not negative 1/4. And so the reason I know it's a negative for sure is just by looking at that line that's going downhill. So we know that should be a negative value. So on targets 4 and 5, so for 4, we are going to be graphing a linear function, and then on 5, we're going to talk about the domain and range. So before we get to the graphing, let's talk a little bit about the domain and range. So these are probably new vocabulary words, but they're going to be super important all throughout our, not even semester, all throughout our year. We will continue talking about domain and range. So domain I'm going to define as all possible x values. Okay, so domain goes with x, and let's think about all we already know about x. So x is our horizontal axis. It goes from the left to the right. So we're going to talk about how far does our graph go to the left, how far does our graph go to the right. So we're going to have a visual in order to be able to answer these questions, which is why we're going to be graphing first. For the range, I bet you can guess what this is. It's all possible y values. Now, if it's y values, think about your y-axis. That's your vertical axis, which means it's going to go down to up. So you're going to ask yourself, how far does this graph go down? How far does it go up? And that would be our range. So like I said, it's much easier to talk about domain and range if we have a visual. So let's talk about how to graph these linear functions. So the first way to graph would be if you're given slope-intercept form like we talked about on the front. So if you're given slope-intercept form, it's really easy. So this last number, this is your y-intercept. So the y-intercept here is 4, so you make a point on the y-axis at 4. Then use your slope, which we talked about on the front, negative 1/3, to find more points. So if it's negative 1/3, that means we're going down 1 over 3. Since it's a negative slope, make sure that your graph is going downhill. And notice that I'm just continuing that pattern of down 1 over 3. And then we'll connect our points. Make at least 3 points to make your graph pretty accurate. So let's talk about those new words, domain and range. So domain. If I asked you how far does this graph go to the left and go to the right, we can see based on these arrows, it goes forever to the left, forever to the right. And so our domain is going to be, I'm going to actually use a symbol. It looks like a crazy R. What this means is all real numbers. This is what you're going to use when I say how far to the left and right does it go, and you think, well, it goes forever to the left and forever to the right. It includes every single possible x value. For the range, remember we talk about down to up, so how far down to how far up. Again, this graph is going to go forever down and forever up. It's never going to stop, and linear functions oftentimes have that pattern, so the range is also all real numbers. Now it does ask for an x-intercept and a y-intercept. So the y-intercept is really easy. It was the first point that we included in our graph, 0, 4. If you forgot, just look at your graph, see where you cross the y-axis at 4, and that point would be written as 0, 4. The x-intercept isn't so easy to see. So one thing that we can do is we could extend our graph. So if we went down 1 over 3 more, you might be able to predict that that number is going to be 12. The other thing that we could do to find that x-intercept is you could plug in 0 for y. So I'm going to go back to that original equation and I'm going to replace the y with a 0. And then we can use our solving skills. So I'm going to subtract 4. So I'm solving for x. So I could divide both sides by negative 1/3, or I could multiply both sides by negative 3. Either way, negative 3 times negative 4 is 12. So we were able to check that prediction. So our x-intercept is at 12, 0. So that was how we would graph if we were given slope-intercept form and we found some information about the graph. Our next graph is in standard form. And so standard form, it's actually a little bit easier to find your x and y intercepts. So we could do some algebra work here and put it in slope-intercept form so that it was y equals. Or we can actually start with the x and the y-intercept. So remember, for the x-intercept, you make y equal to 0, and for the y-intercept, you make x equal to 0. So let's go back to that original equation, and let's start off by making y equal to 0. So this is to find the x-intercept. So I'm just going to replace the y with a 0. Well, 10 times 0, that's just 0. So we can get rid of that. 10 times 0, 0. So we have 5x equals 20. Using your solving skills, you'll know that x equals 4. So our x-intercept is 4, 0. So I wrote it and then I also graphed it. Now to find your y-intercept, we're going to do the opposite. We're going to make x equal to 0. So again, that's just 0. We don't have to worry about it. So really we're looking at 10y equals 20. If we divide both sides by 10, we get y equals 2. So the y-intercept is 0, 2. Now we have 2 points. We can actually go ahead and graph with just 2 points. That would be fine. So again, this is just giving you another way to think about this. You could have put your equation in slope-intercept form and attacked it exactly how we did on A, but you can also just find the x and the y-intercept. Let's talk about domain and range. Remember domain, how far to the left and right. This graph is very similar to the first one. It goes forever to the left, forever to the right, so all real numbers. The range, how far down to how far up. It's going to go forever down, forever up. We will see an exception to that rule. It's not always going to look like that for the domain and range. Okay. C looks a little bit different because it's just y equals a number. Notice there's no x's in this problem. So whenever you have y equals a number, that's just a horizontal line. So just filing that away to like the horizontal line versus vertical line, what does that look like? If it's y equals a number, no x's, it's a horizontal line at that value. So we're just going to make a horizontal line at -4. So once we have our graph, we can ask ourselves, what's the domain? How far to the left and right? Well, we can see a horizontal line is going to go forever to the left, forever to the right. So again, we have all real numbers. Range, we ask ourselves how far down to how far up. In this case, the horizontal line doesn't go up or down at all. It just stays at that one y value. So in this case, the range is not all real numbers. We just write y equals -4. This graph never crosses the x-axis, and it never will. So no x-intercepts. And for your y-intercept, we can just see it based on the graph. It's at 0, -4. Our last equation, you can attack several different ways. It just kind of looks like it's in a funky form. So what I'm going to choose to do is put it in slope-intercept form. So slope-intercept form is that y equals, and guys, this is a great way to just always go back to. When you're uncertain about how to graph a line, make sure it's in slope-intercept form. It's y equals mx plus b. Then go ahead and graph it. So I'm going to write over here to the right. I'm going to rewrite the equation, but I'm going to distribute the 2. So y minus 6, that hasn't changed, 2x minus 8. And then I'm going to make this y equals, so I'm going to add 6 to both sides. So the y-intercept form, slope-intercept form would be y equals 2x minus 2. And then we're going to graph this the first way that we did, so on example A. So the y-intercept is negative 2, and the slope is 2. So think about that as 2 over 1. So up 2 over 1. Up 2 over 1, and continue that as much as you would like. So we have a pretty steep line going upwards. Domain. How far to the left and right is this graph going to go? It's going to go forever to the left and right, and it's going to go forever up and down. So the only cases that we have that are a little bit strained with the domain and range would be a horizontal line like we saw in example C, but also a vertical line, which we didn't see an example of, but you will see on your homework. The x-intercept, I can just see that on my graph. I don't have to do any solving. It's at 1, 0. The y-intercept is at 0, negative 2. So we have all you need to know about linear functions when it comes to graphing and the rate of change for targets 3 through 5.